Welcome back guys to the another video, the reference models. So it goes like that. So a reference model is like a blueprint that defines how different parts of network should interact, ensuring smooth communication between devices. Like example, you can take a building. Imagine building a house where each construction phase has specific tasks like foundation, walls, roof. Similarly, a reference model like OSI divides network communication into layers, each handling specific functions. This modular approach allows different systems to follow the same structure, promoting compatibility and efficient communication. Here we have the OSI and TCP/IP layer diagrams, which shows the different kinds of layers in both of them. So we have the OSI model that stands for Open System Interconnection, which is a reference model that describes how information from software application in one computer moves through physical medium to the software application in another computer. This OSI basically consists of 7 layers, and each layer performs particular network function. This OSI model was developed by International Organization for Standardization in 1984, and it is now considered as an architectural model for the intercomputer communication. So, why was the need for constructing such kind of models? Because the each computer machine companies later in back days, they were having their own kind of stuffs languages to communicate between the computers. So there was a necessary requirement for making such kind of model which can interact over all the computers in the world. So they have developed some kinds of models like OSI model and all. So the basic work of the OSI model is it divides the whole tasks into 7 small and manageable tasks. Each layer is assigned a particular task. Each layer is self-contained so that the task assigned to each layer can be performed independently. And the OSI model is divided into 2 layers, the upper layer and the lower layer. So we see the all the 7 layers. So first one is physical layer, the bottom one. The primary purpose of it is to define hardware aspects of communication such as data transmitted over physical media and transmission media that deals with the transmission and reception of raw binary data over various physical media types including cable, fibers and wireless transmission. The main function of the main functionality of the physical layer is to transmit the individual bits from one node to another node. It establishes, maintains, and deactivates the physical connection. It specifies the mechanical, electrical, and procedural network interface specifications. The functions are like line configuration that defines the way how two or more devices can be connected physically. Data transmission that defines transmission mode, whether it is simplex, half duplex, or full duplex mode between two devices on the network. Then the topology, which is used how network devices are arranged to get the best efficient output, and the signals, which determine the type of signal used for transmitting the information. Then we have the data link layer that is responsible for the error-free transfer of data frames. Here the data is converted into frames and it defines format of the data on the network. It provides the reliable and efficient communication between two or more devices and it's also responsible for unique identification of each device that resides on a local network. It is mainly responsible for unique identification of each device. It consists of two sublayers that are logical link control layer and the media access control layer. Logical link layer is responsible for transferring the packets to the network layer of the receiver that is receiving. It also provides flow control. Then the media access control layer is link between logical link control layer and network's physical layer. It is used for transfer of the packets over the network. The functions of data link layer are many. It provides a way for sender to transmit a set of bits that are meaningful to the receiver. The data link layer adds the header and trailer to the frame. The header, which is added to the frame, contains the hardware destination and source address. Then we have the physical addressing. The data link layer adds physical addressing MAC addresses of the sender and receiver in the header of each frame. The frame is transmitted to the destination address mentioned in the header. Then the flow control comes into picture. The main functionality of the data link layer is the flow control. It is the technique through which constant data rate is maintained on both sides so that no data gets corrupted. It ensures that transmitting stations such as the server with higher processing speed does not exceed the receiving station with a lower processing speed. Then the error control is there, where the data link layer provides the mechanism of error control in which it detects and retransmits the damaged or lost frames. Here, the error control is achieved by adding the cyclic redundancy check that is placed to data link layer's trailer, which is added to the message frame before it is sent to the physical layer. If any error seems to occur, then the receiver sends the acknowledgement and retransmission of corrupted frames. Then we have the access control. When two or more devices are connected to same communication channel, then the data link layer protocols are used to determine which device has control over the link at a given time. Moving on to the network layer, that determines the best path to move data from source to destination based on the network conditions, priority of the service, and other factors. It is responsible for routing and forwarding the packets. The routers are the layer 3 devices that are specified in this layer and is used to provide the routing services within an internetwork. The protocols used to route the network traffic are known as network layer protocols, which includes IP and IPv6 as their examples. The functions of network layer are internetworking. That is the main responsibility of network layer. That provides a logical connection between different devices, addressing and routing, the packet sizing. Network layer receives the packets from upper layer and converts them into packets. This process is known as the packet sizing. It is achieved by Internet Protocol. Then we have the transport layer. It ensures messages are transmitted in the order in which they are sent, and there is no duplication of data. The main responsibility is to transfer data completely. This layer can be termed as an end-to-end layer, as it provides a point-to-point connection between source and destination to deliver the data reliably. So it can be the main layer of the entire of the model. The two protocols used in this layer are transmission control protocol that allows systems to communicate over internet and establishes and maintains a connection between hosts. And the other is user datagram protocol, that is an unreliable transport protocol, as in this case receiver does not send any acknowledgement when packet is received. The sender does not wait for any acknowledgement, therefore this makes the protocol unreliable. The functions of transport layer include service point addressing, segmentation and reassembly, and connection control, flow control, and error control. The transport layer is also responsible for current error-free delivery. Error control is performed end-to-end rather than across the single link. The sender transport layer ensures the message reach at the destination without any error. Then we have the session layer. The session layer is used to establish, maintain, and synchronize interaction between communicating devices. The functions of it includes dialog control, where the session layer acts as a dialog controller, that it allows communication between two processes, which can be either half duplex or full duplex. And we have the synchronization. Session layer adds some checkpoints when transmitting the data in a sequence. If some error occurs in the middle of the transmission of data, then the transmission will take place again. Then the transmission will take place again from the checkpoint presentation layer. That is mainly concerned with the syntax and semantics of information exchanged between the two systems. It basically acts as data translator for a network, and it does encryption, which means that, like when we send a message in WhatsApp to a contact, so the message is to be reached safely. For that we do encryption, in which no one in between which wants the message to be forged or to be seen cannot make any changes and cannot understand the message. And we have the application layer, which serves as a window for users and application processes to access network service, handles issues such as network transparency, resource allocation, and like that. It performs application layer functions, provides the network services to end users. The functions of it includes like file transfer, access and management, mail services, where an application layer provides the facility for email forwarding and storage. Then the directory services, in which an application provides the distributed database source and is used to provide the global information about various objects. Then let's take an example of considering the process of transferring a file for better understanding. So the layer 1 is physical layer, where transmits the raw bits over the physical medium, and in data link layer that is responsible for establishing a point-to-point link for data transfer. Then the network layer determines the best route for file through the network, and then we have transport layer breaks the file into manageable segments and ensures reliable and delivery. Then the session layer comes into picture that establishes and manages the session for file transfer, and the sixth layer is the presentation layer that prepares the file for transmission, and application layer initiates the file transfer. Now moving on to the TCP/IP model that was developed prior to the OSI model. The TCP/IP model is not exactly similar to the OSI model. The first four layers provide physical standards, network interface, internetworking, and transport functions that correspond to the first four layers of the OSI model. And these four layers are represented in TCP/IP model by a single layer called application layer. Here you see a word hierarchical, which means that each upper layer protocol is supported by two or more lower level protocols. Functions of TCP/IP layers are network access layer, internet layer. The first one is the application layer, which provides applications with standardized data exchange. The protocols include HTTP, FTP, Post Office Protocol 3, Simple Mail Transfer Protocol, and Simple Network Management Protocol. Here the payload is the actual application data. Then we have the transport layer that is responsible for flow control, reliability, and correction of data which is being sent to the network or the network. The two protocols used in transport layer are user datagram protocol and transmission control protocol. In UDP, it provides connectionless service and end-to-end delivery of transmission. It is unreliable protocol as it discovers the errors but not specify the error. The UDP consists of fields like source port address. It is the address of the application program that has created the message. Then the destination port address is the address of the application program that receives the message. Then we have the total length and checksum. Then we have the network layer. The network layer is also called as the internet layer that deals with packets. And connects independent networks to transport the packets across network boundaries. Network layer protocols are IP and Internet Control Message Protocol that is used for error reporting. Then we have the physical layer that is known as the network interface layer or data link layer. It consists of protocols that operate only on link. The network link component, the protocols in this lowest layer include internet, local area networks, and address resolution protocol. So the uses of TCP/IP are TCP/IP can be used to provide remote login over the network for interactive file transfer, to deliver mail, to deliver web pages over network, and to remotely access a server host the file system. It is used to represent how information changes form as it travels over a network from the concrete physical layer to the abstract application layer. It also details the basic protocols or methods of communication at each layer as information passes through. Then taking an example of process, considering the process of web browsing, where the physical layer handles actual transmission of electrical or optical signals over the physical medium, then the link layer transmits data packets over the local network using technologies like Ethernet or Wi-Fi. Then the internet layer routes the request through the internet using IP addressing. The later moved on to the transport layer, establishes a TCP connection to ensure reliable data transfer. And the last fourth layer, which consists of the three similar layers of OSI model, which initiates the web browsing request using a specific application protocol like HTTP. Thank you for being with me till the end.